Hi, welcome back. In this video, I will deep dive into my code used to create the practiceforums_1 test case that I demoed in my last video. If I had to choose only one video for you to watch in order to get a good feel for my coding style, this would be the one. But it would really be best to see all of them. Again, these videos are not made to teach anyone how to automate, but instead to show what my style of coding is. Many of my videos are easy for anyone with little to no automation experience to follow along with. This video is not one of them. You should have some experience with programming or Selenium automation in order to follow along with this video fully. If you want to see the next video that is easy to follow along, please see the description below for the next recommended video. This will cover the main methods I already briefly covered that are directly called in the test case method, which is the pop and verify methods, so make sure to watch my previous video before watching this video. For each web page that needs to be automated, I usually create a method named pop and another one named verify. In this video, I will show you the code used to create the pop and verify methods, as well as some of the main methods embedded in them. These are two of the most common methods used to create all my test cases. They are very similar to the common methods I have created in the past 20 years and used in my automation frameworks developed in other languages and automation tools, such as with C# and Qtp. Here's the test case that was demoed in the last video. This is the code that populates data into the practice forms page and does actions such as clicking on buttons and selecting checkboxes. Pop is the method I created to do this. Each web page will have its own unique method named pop, but they are all designed in the same style and call a method that has the same name, pop. Let me show you the pop method code. Here's the code for the pop method. At the top, there is a sample call to the method that is commented. It's there as a template, so if an automation engineer wants to use the pop method, instead of writing it all out by hand, they can copy and paste the template into their test case, and then change the values for each element or delete the lines they do not need. In the signature, the hashmap object popData is passed in. PopData contains the key value paired collection of the names of the elements to do actions to, and the value or actions to do. The first line in the method creates an object of the ActionsUD class. The ActionsUD class is where I stored methods I created for most of my common methods. These are generic methods, meaning that they can be reused in any web application. EnterFieldData is the only method used in the pop method, but sometimes variations of it is necessary instead. For each element on the web page, this method is used once. This method does the actions and reports the test steps. 3 arguments are passed in. The first argument is the element to do actions to. I implemented the page object model using Page Factory in my Selenium framework in order to reference objects declared as web elements in my code. Here's the code to identify the last name text field. The web element last name is the reference to the element. This is the web element that is passed in as the first argument. The second argument will be the value set or action implemented on the web element. The code here gets the string value of the specified key in the popData hashmap, which in the template is set here. The third argument is what will be written in the results report as the name of the element in the web page. I create a string for each element and pass it in as an argument. The string is written here next to where I declared the web elements. In other languages, I have been able to extract the name of the web element using code, so I did not need to use this third argument. But from what I recall in my research, that is not possible in Selenium if you're coding in Java. For radio buttons and checkboxes, an additional fourth argument is required, at least for this web AUT. 2 web elements are required to be passed in instead of 1. One web element is the one that Selenium needs to click on, and the additional one is the web element, an invisible element, that contains the value indicating if the radio button and checkbox is selected or not. So these 2 additional methods were created for them, as you can see them grouped here. This group for the radio buttons, and this one for the checkboxes. In the near future, I may use method overloading for these 3 methods so that only one needs to be used. Here are the definitions for the 3 methods that do actions to the web elements. They all call a master method, EnterFieldData_LF, that does all the real work. I already covered all the arguments that the 3 methods take in. The master method takes in the same arguments, plus one more, a flag to indicate there is an invisible object where the actual value needs to be retrieved from. So these 3 methods all call the master method, EnterFieldData_LF. In the master method, the first thing it does is determine if the method really is to do anything. If the value or actions is not set, that means no value or actions is to be executed, so the execution flow leaves the method. This logic is beneficial because the pop method needs to be coded using this master method for every web element in the page, and often not all elements will be required to be acted upon when the pop method is called in a test. This is desirable in data-driven test cases too, as I will explain to you in the video for data-driven test cases. If the execution flow is to continue, then it checks to see if the value to be set is to clear the text. If the string null is passed in for the value argument, then text in a text field will be deleted. This section of code waits for the web element to exist. It synchronizes with the web element, meaning it only waits as long as it has to, so the execution flow continues as soon as the web element displays. This is so no extra time is wasted waiting, so execution is as quick as possible. So this is not the same as a wait or a sleep statement, which waits the full entire time that you tell it to wait or sleep for. This is the method I created to return the boolean true once the web element exists. If it times out, it will return false. Selenium has its built-in waits, implicit, explicit, and fluent waits that I've used in the past. The method I created here, and similarly in many projects over the last 20 years, has worked perfectly and has some advantages that I will cover in a later video that is specific to the framework functions I created. If the master method is dealing with radio buttons and checkboxes, then the invisible elements I mentioned before that contain the isSelected value needs to also exist before continuing the workflow. The usual wait methods do not work for these items, so this code is used instead. This will later be coded as a method where it will wait more than just instantly. If a web element does not exist, the writeStep_result method will report the step as a failure. A hard assert method call reports the same failure to my log report, the log you saw during the test run, and this will also stop the test case execution so that the next test case can start as soon as possible. But if the web element does exist, the execution flow continues in the master method. The next section is used to determine what type of web element is being tested. GetAttribute method can be used to get the type. Sometimes there is no type available to get. In that case, the tag can be captured instead and used as the type going forward. The type is passed into the switch case clause. The type tells the code what action is to be placed on the web element. Here are examples of 3 different actions. The first one is sendKeys, which is used for fields where you can type in characters. The second one is select by visible text, which is used for elements where you can select items from a list of items. The last one is click, for actions such as clicking on a button. After each one of these actions is done where a value is set, the next line of code gets the value of the same web element. Later in the code, this actual value will be compared to the expected value to report if the step was successful or not. For radio button and checkbox actions, it is a little bit more complicated. We need to first find out if it is selected or not, then use logic to determine if the web element should be clicked. For example, if you want to have a checkbox selected, you only click it if it is already unselected, because clicking it if it is already selected will cause it to be unselected. So in this case, actually doing nothing to the checkbox would satisfy this step. The case for clicking the file buttons, like that for the Choose File button in the Practice Forums page, is not straightforward either. It requires the use of the JavaScript executor. The switch case statement ends with the default clause. I use this to inform the automation engineer that this type of web element is not coded for. A similar message as a test step failure is reported in the test results and the log using my writeTestSteps method and the assert method. After the action is completed and the actual value is retrieved, this next section of code executes. This code compares the actual value to the expected value. The expected value is the value that was passed into this method. Depending upon if the value matches or not, will determine what will be reported to the test results. The variables holding the report message and status of the test steps are set here. Then these 2 variables are passed into the writeStepResult method, where it will report the test steps as passing or failing into the HTML reports. If the test step failed, the assert method will stop the test case execution just like it would have in a number of other places coded for in this master EnterFieldData method. We want to make sure the test case does not continue because if a step cannot successfully complete, the remainder of the test is no longer valid. If all goes well, the execution flow continues and leaves the master method and the test case continues. That ends my deep dive in explaining my code for executing actions on the web elements. As a quick review, in my test cases, I pass a hash map containing the names of all the web elements and their actions or values to execute on a web page into a single method named pop. The pop method then, for each web element, calls an EnterFieldData method. The code to verify web element values is very similar to the action methods. Now, let me show you the code to verify web element values. Here's the pop method again. And here's the verify method. This calls 3 variations of the VerifyField method. These methods only need to get values. It doesn't need to set values in the web element, like the pop method does. Here are the 3 variations of the VerifyField methods. There's actually 4 variations, not 3. But the first 3 methods only do default verifications. I coded them to verify the value that is most commonly tested on a web element. This fourth one, VerifyField second part of inner text, also calls the master VerifyField method. But this one, when it calls the master VerifyField method, uses a set of optional property arguments. This tells the master VerifyField method not to verify the default value, but rather some other web element property. Let me show you what is special about this method. Here's a screenshot of me inspecting this static text. This text will change depending upon the color selected in the select field above it. Often I will get test requirements that would only need the color in the static text to be verified, and not the "you selected" text before it. But the inspector shows the entire text, so I need to parse out just the color part. Here's the code to do that. This code gets all the text. When the optional parameter is set to second part of inner text, then this code, a method I created, is executed to parse out the color instead of the entire text. This method takes 2 arguments. The first one is the entire text. The second one is just the first part of the text, in this case, the string "you selected:". Now, only the color is the actual value that would be compared with the expected color to see if the verification passes or fails. There are many other properties that can be verified. For instance, for a select field, instead of the default verification that verifies the correct list item is selected, in this case red, an optional parameter could be used where we could set it to item count, so I could verify the number of list items available to select from is correct, or list of items to verify all the expected list items are available. There are many other properties that can be verified. I will show that code in a future video. This ends the video covering the main parts of the pop and verify methods. Methods I created to write test steps, wait for web elements to exist, and other methods that were briefly covered in this video will be covered in more detail in future videos. Please look in the description below this video for the link to the next video to watch. My email address is there too, in case you want to send me any questions, and then I will reply back with an answer as soon as possible. Thank you for watching.